Here's the solution to day 4, problem 1. A fire hydrant is 2.5 feet high and casts a 5-foot shadow. At the same time, a nearby tree casts a 17-foot shadow. Question A, sketch a diagram. So for a fire hydrant, how about a simple little rectangle shape? And here's the ground. Now we're also told that there's a nearby tree. Now, a tree is probably taller than a fire hydrant, and so let's say this is the tree. Now we're told that the fire hydrant and the tree cast a shadow on the ground. For there to be a shadow, the sun has to be out. And so the sun is way up high in the sky, but to get it to fit on our paper somewhere, let's say the sun is up here in the sky. And from the sun, there are the sunbeams coming out, right? Sun rays are shooting out from the sun. Now, how shadows are formed is a ray from the sun will come down through the sky, and it will just clip the top edge of an object, and then it continues to come down, right? And all the way until it strikes the ground. And all of this is going to remain bright. But where the tree is blocking the sun and it can't get through, and this sun ray can't get through the trunk of the tree, that creates a dark spot on the ground. And that's what a shadow is. Okay? And it's the same for the fire hydrant. Right here, the sunbeam can get past the fire hydrant and make this be bright, but all of this on the ground is blocked from the sun, and so it's a darker spot on the ground. And so here is the shadow for the fire hydrant, and also along the ground you have the shadow of the tree, because the tree is blocking the sunbeams from coming through and keeping the ground bright through here. Okay. Now, in a math class, we're able to recognize some shapes within a diagram like this. There are some triangle shapes, specifically right triangles. If we focus our attention here at the fire hydrant, we're able to see a small right triangle shape, like this, with a 90-degree angle in the corner. We're told that the fire hydrant is 2.5 feet high, so this side of the triangle is 2.5 feet. And we're told that the shadow on the ground for the fire hydrant is 5 feet long. And so from here to there is 5 feet. Now let's focus our attention on the tree. We're told that the shadow of the tree is 17 feet. So from the base of the tree, all this dark area on the ground, all the way to here is the shadow of the tree. So across there, that's 17 feet. Now, what about the height of the tree, right? We've got this right here. That's the height of the tree. And then here's the diagonal side. And then right the shadow across the ground would be the shadow for the tree. This is also a right triangle shape. And it's a similar right triangle to the small one. They are the same shape. This one here is just much larger. Okay. What we do not know is how tall is the tree. And since we don't know that, we can use a variable to represent it. For instance, maybe the letter X could be written on this side of the triangle. Okay. So here is our diagram for part A. Now in part B, use similar triangles and a proportion to find the tree's height. Our diagram shows the similar triangles. We have a small right triangle. We have a larger right triangle. They are similar in shape. Okay? And we're told to use a proportion to find the tree's height. So let's create a proportion from those similar triangles. What a proportion is it's an equation, so it has an equal symbol in it. And on both sides of the equation, there are ratios or fractions. So there's going to be a ratio to the left of the equals and a ratio to the right of the equals. Let's figure out what numbers to use for the numerator and denominator, and over here for the numerator and denominator. Let's begin by focusing on the small triangle that has to do with the fire hydrant, and create a ratio between the height of the fire hydrant and the length of its shadow. The height of the fire hydrant is 2.5 feet. And let's compare that to its shadow, 5 feet. And so I'm making a ratio between these two measures that have something to do with the fire hydrant. I'm taking the height of the fire hydrant and putting it on top of the fraction, and I'm putting the shadow for the hydrant on the bottom. Just remember that order. The height on the top, the shadow on the bottom. Okay. Let's go over and look at the tree now. Okay. On top, the height of the tree. That's where we put X. And on the bottom, the shadow of the tree. That's the 17. So here is a proportion that shows relationships between a fire hydrant and its shadow and a tree and its shadow. Now there are a lot of ways to solve proportions. Okay? If we can see any sorts of patterns, those patterns can help us to solve for the variable x. And there is a pattern that I notice. The pattern has to do with how the height of the hydrant is related to its shadow. 2.5 is half of 5. That's a pattern that I see, and I can use that pattern to find the height of the tree. Okay. So if the fire hydrant is half its shadow, then the tree will be half of its shadow. So what number is half of 17? And as we think about this, the answer for x will turn out to be 8.5. 8.5 is half of 17. And so without actually measuring the tree, climbing up in it, putting a tape measure down to the ground, we're able to use math and geometry to find its height by noticing something that's true about an entirely separate object from the tree. Now, day 4, problem 2. Simplify each expression, and notice there are 4 math questions to do. So let's start with question A. -4 times -7. Negative number times a negative number is positive. 4 times 7 is 28. Question B. 50 divided by -5. Positive number divided by a negative number is negative. 50 divided by 5 is 10. Question C. This one is about subtracting fractions. Subtracting fractions, like adding fractions, means that the fractions have to have the same denominator. And right now, these are not the same denominator, so let's rewrite these fractions so that they're equivalent fractions, but with the same denominator. If we multiply this by 4 and its numerator by 4, then this becomes 8/12. 8/12 of something is equivalent to 2/3 of the something. Now let's change this fraction so it also has a 12 as a denominator. Multiply by 3 and multiply its numerator by 3. This will become 3/12. Now we can subtract them. 8/12 of something subtract 3/12 of the something is 5/12. Now question D. 5/8 divided by 1/2. We have 5/8 to begin with, and we want to divide by a half. We want to find how many halves are there in 5/8. Now, this is a little complicated to try to think through in your mind. Fractions is not the easiest thing to divide mentally. And so a way to do this is to rewrite this as a multiply problem. We can rewrite this as 5/8 times. Now, dividing by a half is equivalent to timesing by 2/1. 2/1 is the reciprocal of 1/2. And by rewriting the division problem as a multiplication problem, it makes it easier to work out. 5 times 2 is 10. 8 times 1 is 8. we get 10/8. Now this does reduce. The top and bottom can both be divided by 2. 10 divided by 2 is 5. 8 divided by 2 is 4. And so our final answer is 5/4.